There's a hidden hero inside every sewage treatment plant, and it quietly protects our environment every single day. Today, we uncover the truth behind one of the most underestimated parts of wastewater systems, the drain valve, and its critical role. You may think treatment is all about massive tanks, filters, and aeration units, but often the biggest threats come from the smallest parts. One simple drain valve can decide whether clean water flows out or a major ecological disaster unfolds, and that consequence is real. Welcome to the drain valve dilemma, where operation maintenance and judgment intersect with environmental risk. Over the next 5 minutes, we will explain valve function, common failure, safe procedures, and a practical checklist for operators. At first glance, a drain valve looks like any mechanical device, but inside it controls flow, isolating drains, and protecting downstream processes. In animation, we label the valve body seat, disc stem, and actuator so you can see how each part contributes to sealing, opening, and throttling flow. Common valve types in plants include gate valves, plug valves, ball valves, and butterfly valves, each suited to different pressures and services. A properly seated valve prevents backflow, retains containment during maintenance, and ensures treatment stages remain uncontaminated, which keeps the system compliant. Automation adds sensors and actuators, but mechanical, where debris and improper operation still cause most valve failures despite electronics. We will now cut between animated diagrams and real plant footage so you can see valves in action under live conditions. When a drain valve fails, consequences escalate. Quickly untreated effluent can contaminate rivers, harm wildlife, and breach permits. Even small persistent leaks cause cumulative pollution, regulatory fines, and loss of public trust, so no leak is trivial. Common failure causes include corrosion, mechanical, where packing failure, actuator faults, and human error during isolation, each leaving clues to follow. Watch this real incident where a stuck valve led to bypassing treatment, visible surface foaming, and an urgent response from operators. Quick detection matters. Flow anomalies, pressure drops, unusual odors, or unexpected alarms often signal valve compromise and demand immediate verification. Proper documentation and incident reporting reduce recurrence. Every event is an opportunity to improve systems training and procedures. Start with safety, isolate energy sources, lockout, tag out, and confirm atmospheric safety before anyone approaches the valve. Perform a careful visual inspection, checking for leaks, corrosion, packing seepage, actuator alignment, and intact fasteners while documenting everything. Exercise the valve slowly through its range, note stiction, binding, or unusual noises that suggest internal issues, and record the symptoms. If the valve will not operate, verify actuator power supply control signals and mechanical linkages before concluding the valve internals are at fault. Minor leaks may be managed with packing adjustment or gasket replacement, while major failures require planned outage isolation and coordinated repairs. Animated cross-sections illustrate inspection points like seat condition disc, where stem threads, and sealing surfaces before you proceed with repair. Safety first, full PP gas monitoring, rescue standby, and clear communication are non-negotiable before any valve work begins. Follow lockout, tag out steps, identify energy sources, isolate bleed lines, apply locks and tags, and verify zero energy state before entry. Environmental controls include deploying temporary containment diversion pumps and absorbents to prevent spills and protect receiving waters during repair. Follow this operator checklist item by item, sign off each step, and hand over to the next shift only after verification. Checklist item 1, confirm valve identification and tag number. Item 2, confirm isolation and zero energy. Item 3, document valve history and recent alarms. Checklist item 4, inspect and test valve operation. Item 5, complete repairs with approved procedures. And item 6, update logs and communicate completion.